Alright, here's another video for 3VT about exercise 10 of the diagnostic test of chapter 6. You see a huge amount of text here, so I always dislike those questions because you have to read all of it. What it is about, it's about workers that are using a crane basket to make repairs on the front wall of an office building. And you see a guy doing some repairs. The crane basket has been lifted to a height of 5 meters. So, a length of 5 meters, sorry, this is 5 meters. And it is in an angle of 33 degrees, because they can set the angle, of course, also like that. Now the bottom of this crane is at 2 meters high, as we can see here, right? And here it says the red horizontal line, but in here I don't have a color, but in your book you can see a red line there. This is all the information that we have. Now what do we need to calculate? We need to calculate the height in meters of the end of the crane basket where it meets the wall. So here, where is that? How high is that point? So we have this triangle here, and we just basically want to calculate that side. And if you calculate that side, in the end we do plus 2, because then we have the total height. So if you take a look at this triangle here, we know the angle. We want to calculate the opposite side, and we know the hypotenuse. So opposite and hypotenuse, that was the sine. So I'm going to write down angle or question A over here. I think I have enough room for that. I'm going to write down sine 33 is the opposite side that we don't know. There are also no letters there, so I'm going to use a question mark. You can also put letters in the picture if you'd like. And then divide it by the hypotenuse. So if you do 5 times the sine of 33, if you calculate that, then you know what that is. So let me see what it is. It's 2.7. So we're going to add 2 to this. And then 2 plus 2.7 is 4.7 meters high. That's how high that is. And that is the answer for exercise A. Then we're going to read this question here. Making repairs at a height of 6.5 meters involves increasing the size of the angle. The angle needs to be bigger. And also, the crane basket arm stays 5 meters long, so just this distance, the truck just going to go backwards towards the building. Okay? What do we need to calculate? Calculate the angle when the crane basket reaches a height of 6.5 meters. Alright, so what we have now is, let me just make a situation of this sketch over here. Here's the building. Now here we have that 2 meters, I mean that stays the same. Now we have a new horizontal distance because the truck moved. I don't know how big this is exactly, but I do know that this arm here, this arm is still 5, and we don't know the angle. In fact, we need to calculate the angle, but we do know this whole height, because they say they make a repair at a height of 6.5 meters. That means that this length is 4.5, right? And this distance we don't know, and we want to calculate that angle. So if you want to calculate that, we use the sine, because we know the opposite side and the hypotenuse. So sine and then 4.5 divided by 5, and if you calculate that, then you have the answer, which is 64.2 degrees. Let's go to exercise C. It says the crane then drives towards the office building to allow the workers to continue their job. How many decimeters should the crane be moved? Alright, so now we actually, because here they didn't move it yet, it doesn't really matter, because then this would just be more like that. But now we want to know how big is this, because here you can see, we still have to calculate how long this is, because then we know that length. And then if we also calculate this length, then we know how much the truck has moved in total. So if you want to calculate this length, right, we're going to do the Pythagorean theorem. So we're going to do the square root of 5 squared minus 4.5 squared. Now if you calculate that, then you will get, let me see if I can find it somewhere, 4.75. So that's this length here. 4.75, does that make sense? No? Oh no, sorry, I made a mistake. I have to do the square root of this. Oh, yeah. That's 2.179. Yeah, 2.179. Otherwise, this could have been 5. It should have been bigger. Okay, so that's this length. And now we also have to take a look at the original situation. And then in the original situation, we have to figure out how big that length was. So we're going to calculate, we are going to use the cosine there. So the cosine of 33 is the adjacent side divided by the hypotenuse. If you do 5 times the cosine of 33, then you know how big this whole length is. So that whole length is, let me see, 4 4.193. So first, this distance was 4.193, then they moved. Let me show you what happened. First this length was 4.193, and then they moved the basket like that, and then the truck drove backwards so they could finish the repairs in the building. And then we want to know what is the difference between those two numbers. So we're going to do 4.193 minus 2.179, and then we need to round it off to one decimal place. So that's 2.0 meters, because then you rounded it off to decimeters. If you want, you can still say it's 20 decimeters, but here it's already been said how many decimeters that is. So this is the answer for exercise 10. Kind of a complicated exercise, but hopefully you could follow it. If you have any other questions, then please let me know. Bye-bye.